Hello everyone, welcome back to the channel. And today videos, we're gonna talk about the DevSecOps Roadmap. Everything you need to learn if you want to build careers in DevSecOps. You've probably already heard about DevOps. DevOps focuses on automation, deployments, and infrastructure. But as systems become larger and cyber attack increase, companies realize something important. Security must be integrated throughout the entire development lifecycle. That's exactly where DevSecOps come in. In this video, I'm gonna talk about complete DevSecOps roadmap, step by step from beginner concepts all the way to advanced security architecture. Let's get started. Number 1, DevSecOps vs DevOps. Before we go deeper, we need to understand the difference between DevOps and DevSecOps. DevOps focuses on continuous integrations, continuous deliveries, infrastructure automations, and faster deployment. DevSecOps adds security into every step of this process. Instead of security team checking system at the ends, DevSecOps integrates security into development, testing, deployments, and monitoring. This means developers, operation team, and security team work together from the beginning. So, security becomes everyone's responsibility. Number 2, scripting knowledge. The next skill you need is scripting knowledge. Automation is extremely important in DevSecOps. Two scripting languages that are commonly used are Bash and PowerShell. Bash is widely used in Linux environments. It allows you to automate tasks like security scan, system configurations, logs analysis, and deployment pipelines. PowerShell is commonly used in Windows environments and enterprise systems. Security engineers often write scripts to automate tasks such as patch management, system hardening, and logs configuration. If you want to work in DevSecOps, automation skill is essential. Number 3, security's foundation. Before learning tools, you must understand security's foundation. One of the most important concepts in cybersecurity is CIA triad. CIA stands for confidentiality, integrity, and vulnerability. Confidentiality means data should only be accessible to authorized users. Integrity means data cannot be modified without permission. Vulnerability means systems must remain accessible when needed. Another important concept is authentications and authorization. Authentication verifies who a user is. Authorization determines what that user is allowed to do. You also need to understand the OWASP Top 10. This is a list of the most critical web security risks such as injection attacks, broken authentication, and security misconfiguration. Finally, encryption protects sensitive data both in transit and at rest. This concept from the foundations of DevSecOps security thinking. Number 4, networking basics. DevSecOps engineers must understand networking. Security control often exists at the network level, for example, firewall filters incoming and outgoing network traffic. They have blocked malicious connection. Another important concept is VLANs, which separates network traffic into isolated segments. You should also understand access control is often called ACL. ACL defines rules that allows or deny network communications. Network segmentation is another critical security strategy. By separating systems into different zones, attackers cannot easily move laterally across the network. This network control helps reduce the attack surface of an organization. Number 1, secure coding. Secure coding is extremely important in DevSecOps. Many cyber attacks occur because of insecure application code. One common vulnerability is actual injection. This occurs when attackers inject malicious actual query into an application database input field. Another common vulnerability is cross-site scripting, also known as XSS. XSS allows attackers to inject malicious script into web page. To prevent these issues, developers must follow best practices such as input validation, parameterized query, and proper output encoding. Security coding practice dramatically reduce security risk. Number 6, identities and access management. Identities management is another key component of DevSecOps. Most organizations use identity and access management, also known as IAMs. IAM control who can access system and resources. One very important concept here is the principle of least privilege. This means users should only have access to the resource they absolutely need. Another approach is role-based access control. Instead of assigning permissions, individuals permissions are grouped into roles. For example, developers, administrators, and auditors. This makes access management more scalable and secure. Number 7, monitoring and loggings. Monitoring is critical for detecting security incidents. Many organizations use a system called Security Information and Event Management, commonly known as SIEM. SIEM platform collects and analyze logs from different systems. This log can include authentication logs, server logs, application logs, and network HFC. Security team analyze this log to detect suspicious behaviors. Alerts can be generated for things like failed login attempt, unusual network traffic, and unauthorized access. Log analysis help organizations detect attack early. Number 8, threat modeling. Threat modeling helps identify potential security threats before systems are deployed. One common model is threat, which stands for smoothing, tampering, repudiations, information disclosures, denial of service, and evaluations of privilege. Another methodology is PASTA, which stands for Process for Attack Simulation and Threat Analysis. Threat modeling involves identifying possible attackers, vulnerabilities, entry points, and potential attack paths. This helps security teams design systems that are resilient against attack. Number 9 is cloud security. Most common system runs in cloud. Major cloud providers include Amazon Web Services, Microsoft Azure, and Google Cloud Platform. Cloud environments introduce new security challenges. One important concept is cloud security posture management. Cloud security posture management tool continuously monitors cloud environments for misconfigurations. Identities management in the cloud is also very important. Cloud platform includes services like key management service, which securely store encryption key. Proper cloud security configuration is critical for protecting modern applications. Number 10, container security. Modern applications often run inside containers. The most popular container platform is Docker. Containers are often managed using orchestration platforms such as Kubernetes. However, container introduce new security risks, for example, vulnerable container image, insecure configuration, and expose secret. To reduce this risk, security team use image scanning tool to detect vulnerabilities before deployment. Number 11, security automation. DevSecOps focuses heavily on automation. Security processes must be integrated into pipeline. One important concept is SOAR, which stands for Security Orchestration, Automation, and Response. SOAR's platform automates security tasks such as incident investigation, alert track, and remediation action. Another important automation practice is automated patching. Systems must regularly update software to fix security vulnerabilities. Automation ensures patches are applied quickly and consistently. Number 12, vulnerability scanning tool. DevOps engineers must know how to scan systems for vulnerabilities. Some popular tools include Nexus, Nmap, OpenVAS, and Qualys. These tools help identify open ports, outdated software, and known vulnerabilities. Regular scanning helps organizations fix weaknesses before attackers exploit them. Number 13, incident response. Even with strong security, incidents will still happen. That's why incident response is critical. Incident response typically include several phases: detections, containments, eradications, and recoveries. Security team may also perform digital forensics to investigate how an attack happens. Finally, organizations conduct root cause analysis to prevent similar incidents in the future. Number 14, security architecture. Advanced DevSecOps Engineer also designs secure architecture. One important principle is defend in depth, which means using multiple layers of security control. Another concept is zero trust architecture, where no system or user is trusted by default. Other important areas include secure API design, network zoning, IDS and IPI system, DDoS protections, supply chain security, and software bill of material, also called SBOM. These strategies help organizations secure large-scale systems. Number 15, governance and compliance. Finally, DevSecOps engineer must understand governance and compliance. Organizations must comply with security standards and regulations. Security teams perform audits and map systems into compliance frameworks. Another important concept is risk quantifications, which help organizations understand the financial impacts of security risks. This allows companies to make better security investment decisions.